I bet you're wondering why I have an xTool D1 sitting next to my Muse here. I'm going to compare these two, so stick around and I'll show you more. If you aren't familiar with laser systems and you go to make your very first purchase, a diode laser like this xTool D1 can be a very tempting prospect. It's small, it's cheap, and some of the things you see people make with it look absolutely amazing. Diode lasers like this one use a solid-state semiconductor device. They're similar to an LED but can generate conditions suitable for generating a laser beam. In fact, diode lasers are more commonly used than you'd think. They are present in devices such as Blu-ray players and even your office printer. The diode laser is mounted to a typical CNC gantry system and moves around the work area to produce the results. Now, with CO2 lasers like this Muse, these features are taken to the next level. CO2 lasers are one of the most versatile types of laser systems currently available. A high voltage flows through a mixture of CO2 and other various gases inside the laser tube, stimulating the gas particles to produce energy, which is then converted into a laser beam. The laser beam that is produced is not visible to the human eye, so it's combined with a red diode so you can visualize the laser beam. The CO2 lasers are mounted in a fixed position, and the laser is bounced through a series of mirrors before it finally makes its way to the focus lens, and then your material. These CO2 machines are typically much larger than a diode system. The glass CO tube alone can be anywhere from 2 feet to 8 feet in length. CO2 lasers have enclosed workspaces which protects you from both a laser beam as well as the high voltage powering the laser tube. This is why CO2 laser systems tend to be much larger than a diode laser system. The sheer raw power that can be produced by a CO2 laser means they can cut through more material at significantly higher speeds than a diode. With just a 40-watt tube in this Muse, it will be able to cut up to 5mm or 1/4 inch material with a single pass. In order to attempt to cut the same material on a diode laser, you will need to take multiple passes at much slower speeds. Because of this, it can take upwards of 10 times longer to cut through materials. And your success will diminish with the thicker materials, as materials will either just melt or burn and char with each pass. And when it comes to engraving, the CO2 will be able to produce engravings that show the same levels of detail as the diode lasers at a fraction of the time. With that in mind, the speed at which a CO2 will be able to complete a job will be much faster, more consistent, and higher quality than what the diode will be able to accomplish. So remember, time is money. While it may be bigger, a CO2 laser like the Muse will help you spend less time waiting, allowing you to make more.